So Alan is 20-something years in InfoSec, and at the moment he's a GRC consultant, but I've done most things. I think that's as good an endorsement as any. So Alan, the stage is all yours.
Okay, thank you. Just let me know if you can see my screen.
We can see a spreadsheet.
Yes, good. So, how to fight a virus with a spreadsheet. It was not a keynote, so I will just change it quickly. There we go. That's a key not. Thank you very much. All right. Yeah, this will be my first time presenting on YouTube. So I had to speak to my kids and work out how to do that exactly. Apparently, I've got to say, hey guys, welcome. Everything's cool. And if you like my chat, then please let me know in the comments below. There are no comments, but you can just like it and subscribe, and there will be great things for you. So yeah, thank you to my kids for letting me know how to do YouTube. All right, I might not know YouTube, but I do know spreadsheets. As I said, I've done a lot of work over the time. And yeah, if you need to get hold of me, you can find me on LinkedIn. You can find me on Twitter. At the moment, yes, senior security consultant for sensor security. That's going to change. Yeah, we're going to be part of CyberCX, part of the CyberCX mafia, I guess. So, jumping back into Tuesday, I believe this was the date. I had to look it up. Tuesday, the 27th of June, 2017. That was a very interesting date. I had a meeting with my manager. Meeting with my manager was to prepare me for a meeting with the CIO and what was called the security board. This was at another company that I was working with at the time. It was a high pressured, and he just wanted to prepare me because we were going to be talking about MS-17-010, also known as Eternal Blue. Anyone that's worked on blue teams or worked in building up, I guess anyone that's worked in security will know exactly what that's about. So it was the day that NotPetya hit. Many Australian businesses and businesses around the world were hit, specifically Maersk and Merck. And yeah, it was a big deal. And the reason why they wanted to speak to me was that I was in charge of patching, and they wanted to put together a war room where we could work out how we're going to patch all our machines quickly on that particular day to make sure that everything doesn't break, and fix everything. And I told my boss exactly what they didn't want to hear because they were quite excited about this, getting the security stuff. I said, we don't need to worry. It's all taken care of. Everything's fine. All our machines are patched against MS-17-010. My boss was, are you sure? I'm like, yeah, I have a spreadsheet and I can show you that. And he was like, oh, okay. And he took it back to them and they were like, are you sure? And he was, yeah, I got a spreadsheet and I can show you and everything's fine. Okay, it wasn't all that easy to get there. So I have to dig back to how it started. So I was hired by the company to pretty much fill up the spreadsheet, dig into all their critical systems, have a look at how they were doing with patching, user management, passwords, etc., etc. Eventually, I managed to sort out the work that I was doing, this piece of work, and we were starting to look at what else can I do. And I said, listen, we can extend the number of critical systems, we can extend the number of security controls that I can take a look at, or what might actually be better is if we actually dig deeper into all the different controls and start working out how we can get even more security and more comfort with them. So the next thing we did, okay, so at the same time, my manager decided to get some big monitors and put them all up and make our place look like it was one of these control centers where everybody was making huge, big decisions about the world and how important we all were. And yeah, I actually searched on Google yesterday or the day before for the term security through big monitors, and I got no results. So I have coined that term, and you are welcome to start using it as long as you credit me for coining the term, security through big monitors. So we got them, and so now all of a sudden I needed to work out how we could make stuff to put onto those big monitors. So what I managed to get hold of was the WSUS. So the WSUS is the system that does all the patching, checks that the patches are done. I managed to get the information from the WSUS. It spits it out into CSVs. CSVs, as you know, can be sucked into Excel. And from Excel, you can start manipulating the data and turn it into manager-friendly graphs. So, moving along, what is a manager-friendly graph? So if you ask anyone, a manager-friendly graph is traffic light all the things. So just on a side note, I was doing a search for traffic lights and came up with this a whole bunch of Quora questions, which either there are a lot of strange people in the world or the robots are actually literally taking up, because they were all asking, how do you actually choose which blocks in the capture contain the traffic lights? But that's just beside the point. Anyway, traffic lights. So we want to get traffic lights. So what we do originally is use the standards that was made for us by the security team. If we have over sort of 90% of patches, we're in the green. If we have over 85% of patches, you know, we have a bit of a problem. Anything less than that, we're actually in the red, and we have serious problems. So I plotted that. You'll see the graph goes up and down because new patches come out, and the team can and can't actually patch them depending on how much time or how much work they put into it or whatever. So it would dip between green and yellow. And that was fine. That went on to our big monitors. It made us look like we were plotting something. But the problem was there was no improvement. You'll see the graph goes up and down, and we have no control over that. And I wanted to work with the technical team and see whether you know, if we could do any better than that. So, to start with, okay, so you have the total number of patches across all the Windows servers, total number of all the Windows servers. So question number one, is this really the total number of patches? And let me just actually make that a little bit bigger. Is it maybe just the total approved patches? So what the technical team could do if they wanted to make their figures look better is just not approve all the patches, just approve the ones that are easy. Or disapprove some patches that they're having problems with and then just never actually approve them ever again. Also, what applications are covered? So if you're looking at just Microsoft applications, you know, Java is one place that people come in. So it is something that people can use to break into your organization, your browsers, etc., etc. So for this example, I was just looking at servers, but we definitely started looking at other packages as well. So that's your applications. Then you have your firmware patches. Databases is an interesting one because what usually you find in an organization, not necessarily this one, is that databases fall in that kind of gap between there's the people that manage the operating systems, there's the people that manage the applications. You have database managers, but they don't necessarily actually do any patching or anything. They just manage access to the databases and the databases themselves. So basically, databases never get patched because everyone's pointing fingers at everyone else. There's actually a Russian saying that that a goat, if it has one owner, will definitely get fed, but if it has two owners, then it might not get fed because each owner will just rely on the other one to actually feed it. And that's exactly where databases fit. Then you have Tomcat. Tomcat is wonderful because it's like all the worst of everything all packaged into one package. So for example, Tomcat uses Java, so you have all the problems of Java. It's a web server, so you have all the problems with web server. It's an application, so you have all the application issues, etc., etc., etc. And you need it. So some organizations rely on it, but obviously, because it fits in between all the different organizations, I mean, all the different departments, no one actually manages it, and so basically, no one actually ever patches it. So that's patches. Do we have all the servers? Servers, that's an interesting case. So are we looking at the Linux servers? Do we have all the ones in the DMZ? Do the DMZs communicate with the way that we're looking at all the patches? So one of the tricks that I found, which was quite interesting, was going onto the virtual machine, the management consoles, and pulling out a list of all those servers and comparing that to all the Windows servers that we were patching. Yeah, and we got some interesting gaps coming through there. And then, yeah, I added number 3 on at a later stage. So there's also your containers. So who manages containers? Who patches containers? Who actually plugs the containers? All the information that's in the containers, who actually patches inside them. Cloud, who manages cloud? How's cloud managed, etc., etc. And of course, if you have home users, bring your own device, who actually patches that, who manages those. Okay. So those were questions that managed to get to make that previous graph more accurate. So I had more machines, more patches. But then I decided, you know what, I've got this information, let's dig into it. And this is actually where it starts to get fun. And this is where I start to get excited about the work that I'm doing. Because I love pulling information from different places, playing with it, experimenting. I believe that this is a very good example of being a hacker. Taking information, working out what to do with it, and not necessarily doing exactly what's expected of you. So if you have a look at the previous graph, you'll see the numbers that I've got. And then if you pull out 1 month's worth of stuff, you'll see it's made up of different computers. Each of those has a total number of patches that they have to have installed, and each of those installed patches, that's the total number of patches that they need, and that's the total number of patches that they actually have installed. So as you'll see, altogether it comes to 93.6. So we're definitely above the limit of what we're looking at. That is the good stuff. We are, we're in the green. Everything's good. We can pat ourselves on the back. But hang on a sec. If you actually dig into the details, you'll notice that it's not all that good. So computer A, for example, is below what we are expecting it to be. Computer J, the same sort of thing. Now, computer E, for example, is 76.5%. It is way below what we're expecting. Now, if someone wanted to actually connect into our network and take over a machine, they're not going to go for computer B or computer C. They'll scan everything. They'll see computer E has issues, and that's the one that they will use, and that's the one that they will pivot from. And that is the one that they'll be able to take over our entire network. So the fact that we are 93.6% compliant across all our different computers doesn't mean that we won't have problems if computer E, for example, is not patched. All right, so a little bit of history. I think I have time to jump into it. Sakichi Toyoda, who started a company which eventually started making cars, which we now know as Toyota. He created pretty much root cause analysis, and he did it simply. He created what they call the 5 whys, as in WHY. So what would happen is if he noticed that something was not as expected, so for example, we expect that there should be 132 patches deployed on computer E. Let me just actually expand that a bit. But 101 patches are deployed, so there's an issue with computer E. So the first thing he would do is ask why. Why is that the case? And the answer is patches are not being deployed to the computer at all. Okay, fair enough. Why? There is a problem with communication between the WSUS and the computer. Why? Okay, well, the computer is in a DMZ and the firewall is blocking the traffic. Okay, fair enough. Why? No rule was configured to allow traffic flow between WSUS and the computer, or between WSUS and the DMZ. Aha, okay, so that already is, we only used up 4 whys, but you could have carried on, I guess. Now we know what the issue is, open up the firewall and allow the traffic through, and ensure that any new DMZs that are created will allow access to them from the WSUS server. Okay, so that's good. That's already starting. And from that, all of a sudden, you get most of the way to getting your machines to be updated. So that's actually a very useful tool. And all it took was diving into the data a little bit, you know, jumping in into more depth into the data. Okay, so just a quick one. So if you have data that you're looking at, many-to-many relationships are not good. One-to-many relationships are nice to have. The problem with that is, as we start digging into our data, and as we start looking at our patches, multiple computers have multiple patches. And that makes life a little bit difficult. So you have to choose what you want to focus on. And so in our case, of course, we want to look at the computers. And so what I did was I managed to get hold of extra information about patches. And so what you'll see, for example, is I've taken, so computer A is missing MS16-003. I've added information from the patch itself that it's call it a high risk vulnerability, and that it was released on the 5th of Jan 2016. Now, what it makes it quite, what is quite interesting here then is that now we've got this extra information that we can work with. We could also, okay, so now we're looking at the 1st of April 20, so that would have come across that is 1,548 days that patch hasn't gone through. These are actually made up figures. I actually didn't jump into and find exactly what MS16-003 actually is, so that could be totally wrong, as well as that these computers are totally made up. So don't assume everything that you see is correct. But it'll give you the point of the matter that these computers have issues because a high-risk vulnerability hasn't been patched for 15,548 days. So now that we have this extra information, it allows us to pull out, to start making rules about the information that we want to look at. So what we can do now is, because we have information, we can work out, okay, that's fine. So we have a process that happens once a month where we do the patches. So if any patch hasn't been done within the last 30 days, that's okay, because probably we haven't got around to it. We're still doing the Q&A. We'll still get around to it. If, for example, there is something that has been patched or hasn't been patched within 30 days, okay, that's fine. It's still within the amount of time that we have to patch, but it probably means that the process didn't happen. And so therefore we need to jump into actually do it. If there is, if it hasn't been patched for 60 days, okay, well then the process has failed twice and now we're running out of time. And if it hasn't been patched for more than 90 days, okay, we have a huge issue. And those are the boxes that you want to jump into. All the others are running quite happily. Those are the ones that we definitely need to take a look at. And then of course, you can graph that. So for our big monitors, we can pop up some Gartner flags and show whether we're actually trending in the right way. And these are actually probably more useful because you can see whether, you know, red is staying stagnant, maybe yellow is getting bigger. Okay, well, that means that we're managing to keep down the number of patches that we haven't done in a long time. But the new ones are making our life a little bit more difficult. And wait a sec. MS17-010 just attacked us. Okay, now that's the problem. So normally what we would do is we chip away patches over time. So we'd look at all our boxes and make sure that each one of them is patching and work out how to keep them patching, all that good stuff. But now all of a sudden we have what I term a critical vulnerability. And my terminology is slightly different to how other people look at it. So I'll just go through mine quickly. So take the Microsoft rating, of course, and yeah, it's critical. So that patch was critical. I then apply what Joshua Corman called H.D. Moore's law, which is a bit of a joke, a bit of a pun on H.D. Moore and then Moore's law. So H.D. Moore, of course, from Metasploit, and Moore's law, meaning stuff gets more powerful over time. Pop them together. So essentially what it means is that if it's easy to exploit in Metasploit, it becomes very critical for you to sort out. So in order, vulnerability is a bad thing. An exploit is worse. An easy exploit is worse, and a worm is worse. So this definitely, from what I could see from the history of this particular vulnerability, was exploited, and then soon after that there was an easy exploit. Soon after that, it looked like it was definitely going to be a worm, and so therefore I dropped everything and said patch this one thing. So going back to level 2, many-to-many relationship all of a sudden becomes the better of the two. Now we don't want the one-to-many relationship, but we want the many-to-many relationship. So we flip everything around, and instead of working out what patches computers have, we work out which of the computers actually have this one specific patch, and we start working on those. And that's what we did at the time. We went through this list, and that's the list that I basically presented to my manager at the time, and said, listen, these are all the computers that we have in the organization. I've been through, I've looked for all the ones that we might be missing. I've got them. And these are all the ones that we've managed to patch. And that's the actual spreadsheet that we sent through. And that is why on that particular day, we were ready for it. So when that one came out, we had no problems with it. And that is pretty much that. I have a few takeaways that I just want to go through. So Number one, get the information. There's always a lot of information out there. So that's a shout out to Sam and Nick, who were very excited with their product, that it's, you know, that they can pull out information from it, make business decisions. Almost everything we run logs somehow. Most of that you can just turn into something that Excel can read. Especially the latest versions of Excel, they're getting better and better at pulling information in. Yeah, number two, play with it, manipulate it, experiment. A shout out to Hannah. This is like a safe place. It's all happening on your computer. You can manipulate it, play with it. You're not breaking anything. And then work out what you want to do. This is something I guess I have to tell myself, because you know, I love to play around with the information. I love to just see how things can work, but the question is, how can we use it to improve things? How can we say, okay, well, you know, your processes are not working. What can the processes do better? How can we improve stuff? What information do people need to make decisions? What patterns can we find? You know, why are these 5 computers not patching? That kind of thing. Ask why. Don't ask it once, ask it 5 times until you get a good answer out of it. You don't need expensive tools. WSUS was in place. All I needed to do was get the okay to get the information from it. My excuse, of course, was, you know, if I can get the information, we can put it on our big monitors and make it look cool. And yeah, I already had Excel. Excel was free, it was on my computer. Yeah, the other thing to note, of course, doing security right is hard. This is one particular security control patching. And I haven't, this is just looking at servers. I haven't looked at workstations, all the different pieces that you might look at. And if you look at the ASD list of things that you should be looking at, there's about 30 of them. And this is just one. So yeah, it's probably just a shout out to all the consultants out there that are like, yeah, you should just go and do ISO 27001 and just do all these 100 controls all at once. It's not easy, and we have to accept that, and we have to understand that. Also, yeah, working with your teams. I suppose another shout out to Hannah. Yeah, you need to work with them. You need to get them to understand that you're helping them. Not necessarily saying you must do this or you must be compliant or this is what's expected, but also a lot of the things that I pulled out here were not, you know, to hit them over the head with, but to actually say, okay, well, these 5 computers aren't updating. What, you know, what can I help with? What is going wrong? What is not happening? And yeah, I guess just keep digging deeper and deeper. You know, the more information you can get, the better your decisions can be. And don't be scared to change your process. So, you know, we were chipping away, you know, 1 box at a time, getting them up and running properly. As soon as we realized, hang on, there's this critical vulnerability, this is going to be a bad one. We changed our process and started looking at that vulnerability specifically. And yeah, so that's the takeaways. And the next steps are, yeah, for you to go out, go and find some information, CSVs, JSON, text, whatever you can get. You know, not necessarily even for security, just do it in your life, work out what's going on in the world around you. And yeah, learn how to join 2 sources together, learn how to pivot, learn how to use graphs, and play around. There's very low risk. Just jump in and do what you can. Sure. Shout out thanks to the Baranov clan, who I believe are watching this at the moment. Hi guys. To Ben Kirk, all the guys at SOS, and to the CCX peeps for, you know, encouraging me and to asking me to do this. Ian, Shanna, ComfyCon AU team, thank you very much for putting this on, for arranging this. it's definitely been an experience. This is the first time that I've been doing a presentation just to myself in an empty room. Hopefully the video is still busy going and I'm not actually just talking to my computer, but either way. And yeah, everyone, thank you very much for taking the time to watch this, especially on a Saturday evening. And just a shout out to the B-Sides team and to Sniff. Yeah, thank you very much for your support. And yeah, good. I'll be taking questions on the question channel if anyone has any. I don't actually know what time I started or how long I've been going. I hope I haven't gone too long.
That's okay. I think Ian's just playing with you at this stage.
I forgot.
Again?
It's kind of a thing. All right.
It's because I wasn't here.
It's because you weren't here, Shannon. Keeping me in chat.
Go.
Thank you very much.
Oops.
Thank you very much, Alan. That was an awesome talk, and I think there's a lot of people who really liked the way that you presented it. Spreadsheets are awesome. As someone who spends a lot of time using spreadsheets, I was going to say something else, and I honestly can't remember what it was. Nope, lost it. Thank you very much again. That was an awesome talk. And yeah, I think there's some questions and some people asking. Oh, that's what it was. I think you should have had a trigger warning when you mentioned Eternal Blue. I know that. I know there's a lot of people, if you said the W word, they probably would have been triggered as well. Yes, no, I remember those days very well, but thank you very much for that.
Yeah,
that was awesome.
Thank you very much for the opportunity.
No worries, mate.